Section 110.26 of the National Electrical Code, or NEC, states that foreign systems are not permitted in working spaces around electrical equipment unless special permission is obtained. Section 110.26 B allows special permission to be obtained prior to installation. The situation involves 24-volt low-voltage termination boxes serving mechanical equipment installed in tight ceiling spaces, where special permission, as allowed by 110.26 NEB, was not obtained prior to installation. The inspector has red tagged the installation due to foreign systems passing through the working space and is refusing special permission, considering it an approval of a code violation. There are possible solutions to address the situation. Firstly, consider appealing the inspector's decision. The installer can appeal to the local electrical inspector or building code official. The argument can be made that the 24-volt termination boxes are an integral part of the mechanical system and are not foreign systems in the electrical sense, and therefore do not pose a significant safety hazard warranting the code violation. Secondly, revise the installation. It may be possible to modify the installation to address the inspector's concerns. For example, the termination boxes could be relocated outside of the working space to a more accessible location, or physical barriers could be installed to protect them from accidental contact or damage. Thirdly, seek special permission with conditions. The inspector might be willing to grant special permission if certain conditions are met. These conditions could include the following. Firstly, ensuring the termination boxes are enclosed in a non-conductive housing to provide an extra layer of safety by preventing accidental contact with any live parts, and secondly, clearly marking the working space as containing 24-volt low-voltage equipment to alert anyone working in the area about the presence of the low-voltage system, and thirdly, restricting access to the termination boxes to only qualified personnel who have the necessary training and expertise to work with electrical equipment safely. Fourthly, consider informational marking. Install an informational marking or label on the termination boxes. The marking should state that the boxes contain 24-volt low-voltage equipment and that special permission has been granted for their installation. This will help inform other workers, inspectors, and anyone else who may come into contact with the equipment that the installation has been reviewed and approved under specific conditions, and that it is not a code violation. It's important to emphasize that any proposed solutions should be discussed with the inspector prior to making any changes to the installation. This collaborative approach can help ensure that the final outcome meets the inspector's requirements and complies with the relevant electrical codes and regulations. When assessing whether the 24-volt termination boxes are considered foreign systems in the electrical sense, consider the following. Firstly, the intended function. These boxes are integral to the mechanical system, not a separate electrical system providing power or control unrelated to the mechanical equipment. Secondly, voltage level. 24 volts is considered extra low voltage, posing a minimal shock hazard compared to higher voltage systems. Thirdly, compliance with safety standards. Ensure the boxes and wiring comply with relevant safety standards for low voltage systems. Fourthly, isolation. Verify that the low voltage wiring is properly isolated from higher voltage systems in the area. Fifthly, accessibility. The boxes should be accessible for maintenance by qualified personnel but protected from unauthorized access. If the 24-volt system is an integral part of the mechanical equipment, poses minimal risk due to its low voltage, and complies with safety standards, one can argue it shouldn't be classified as a foreign system. When preparing to appeal the inspector's decision regarding the 24-volt termination boxes, it is crucial to gather and present a comprehensive set of information and arguments to support the position that the installation does not pose a safety hazard or violate the intended purpose of the electrical code. Firstly, gather all relevant documentation. This includes the original installation plans, product specifications for the termination boxes, wiring diagrams, and any communication with the inspector regarding the issue. Secondly, site-specific code sections. Refer to the specific sections of the electrical code that support the argument that the 24-volt system is not a foreign system or does not violate the code. In this case, focus on 110.26 and related exceptions or clarifications. Thirdly, provide a detailed explanation of the system. Clearly explain the purpose and function of the 24-volt system, emphasizing its integral role in the operation of the mechanical equipment. Show how it is not a separate electrical system, but rather an essential component of the mechanical system. Fourthly, highlight safety features. Emphasize the safety features of the 24-volt system, such as its low voltage level, proper insulation, and compliance with relevant safety standards. Explain how these features minimize the risk of electrical shock or other hazards. Fifthly, address the inspector's concerns. Directly address the inspector's concerns about foreign systems and potential code violations. Explain why the 24-volt system should not be classified as a foreign system and how it meets the intent of the code. Sixthly, offer alternative solutions. Be prepared to offer alternative solutions or modifications to the installation that could address the inspector's concerns while still maintaining the functionality of the system. This could include relocating the termination boxes, adding barriers, or implementing additional safety measures. Seventhly, obtain expert opinions. If possible, obtain expert opinions from qualified electrical engineers or consultants who can provide additional support for the argument. Their expertise can lend credibility to the appeal. Eighthly, prepare a written appeal. Compile all of the information and arguments into a well-written appeal letter or document. Clearly state the reasons why the inspector's decision should be overturned and provide supporting evidence. Ninthly, request a meeting. Request a meeting with the inspector or the local electrical authority to discuss the appeal in person. This will allow to present the case and answer any questions they may have. Tenthly, be respectful and professional. Throughout the appeal process, it is important to remain respectful and professional. Avoid confrontational or argumentative behavior, and focus on presenting the facts and arguments in a clear and logical manner. By following these steps and presenting a well-reasoned and supported appeal, you can increase the chances of overturning the inspector's decision and resolving the code violation issue. When considering relocating the termination boxes as a solution to the code violation issue, it is essential to carefully evaluate several factors to ensure that the new location is suitable and meets all relevant safety and code requirements. Firstly, accessibility. Ensure that the new location is easily accessible for maintenance and inspection by qualified personnel. The termination boxes should not be placed in a location that is difficult to reach or requires special equipment to access. Secondly, environmental conditions. Consider the environmental conditions of the new location, such as temperature, humidity, and exposure to moisture or corrosive substances. The termination boxes should be protected from environmental factors that could damage them or compromise their safety. Thirdly, clearance and working space. Ensure that the new location provides adequate clearance and working space around the termination boxes, as required by the electrical code. This will allow personnel to safely work on the equipment without being obstructed by other objects or structures. Fourthly, proximity to other equipment. Consider the proximity of the new location to other electrical or mechanical equipment. The termination boxes should not be placed in close proximity to equipment that could generate excessive heat, vibration, or electromagnetic interference. Fifthly, code compliance. Verify that the new location complies with all relevant electrical codes and regulations, including requirements for wiring methods, grounding, and overcurrent protection. Sixthly, aesthetics. While functionality and safety are the primary concerns, also consider the aesthetics of the new location. The termination boxes should be placed in a manner that minimizes their visual impact and blends in with the surrounding environment. Seventhly, cost. Evaluate the cost of relocating the termination boxes, including the cost of materials, labor, and any necessary modifications to the surrounding structure or equipment. Eighthly, feasibility. Assess the feasibility of relocating the termination boxes, taking into account any physical constraints or limitations of the building or equipment. Ninthly, documentation. Document the new location of the termination boxes in the electrical plans and provide updated wiring diagrams and labeling. Tenthly, communication. Communicate the changes to the inspector and obtain their approval before proceeding with the relocation. By carefully considering these factors and obtaining the necessary approvals, one can ensure that the relocation of the termination boxes is done safely and in compliance with all relevant codes and regulations. When implementing barriers to protect the termination boxes, it is essential to select appropriate materials and designs that provide adequate protection without compromising accessibility or ventilation. Firstly, material selection. Choose barrier materials that are durable, non-conductive, and resistant to environmental factors such as moisture, temperature, and corrosion. Common materials include plastic, fiberglass, and metal with a non-conductive coating. Secondly, barrier design. Design the barriers to provide adequate physical protection to the termination boxes, preventing accidental contact or damage from tools, equipment, or personnel. The barriers should be sturdy and securely mounted to prevent them from being easily dislodged. Thirdly, accessibility. Ensure that the barriers do not obstruct access to the termination boxes for maintenance and inspection. Consider using removable panels or doors that can be easily opened or closed as needed. Fourthly, ventilation. Provide adequate ventilation to prevent the termination boxes from overheating. The barriers should not restrict airflow around the equipment, and ventilation openings may be necessary to dissipate heat. Fifthly, code compliance. Verify that the barriers comply with all relevant electrical codes and regulations, including requirements for clearances, grounding, and fire resistance. Sixthly, visibility. Consider the visibility of the termination boxes behind the barriers. If necessary, use transparent or translucent materials to allow for visual inspection of the equipment without removing the barriers. Seventhly, labeling. Label the barriers to indicate the presence of electrical equipment and to warn personnel to exercise caution. The labels should be clear, legible, and durable. Eighthly, installation. Install the barrier securely and in accordance with the manufacturer's instructions. Ensure that all fasteners and mounting hardware are properly tightened and that the barriers are properly aligned. Ninthly, maintenance. Regularly inspect the barriers for damage or deterioration and repair or replace them as needed. Keep the barriers clean and free of obstructions. Tenthly, documentation. Document the installation of the barriers in the electrical plans and provide updated drawings and specifications. By carefully considering these factors and implementing appropriate barrier designs, one can effectively protect the termination boxes from damage and prevent accidental contact with live electrical components. When seeking special permission with conditions from the electrical inspector, it is essential to demonstrate a proactive and cooperative approach, presenting a well-thought-out plan that addresses their concerns while maintaining the functionality and safety of the electrical system. Firstly, documentation. Gather all relevant documentation, including the original installation plans, product specifications for the termination boxes, wiring diagrams, and any previous communication with the inspector. Secondly, code analysis. Conduct a thorough analysis of the applicable electrical codes and regulations, identifying any potential violations or areas of concern. Be prepared to discuss these issues with the inspector and offer solutions that comply with the code. Thirdly, risk assessment. Perform a risk assessment to identify any potential hazards associated with the installation and propose mitigation measures to minimize these risks. This could include installing barriers, providing additional insulation, or implementing safety interlocks. Fourthly, alternative solutions. Develop alternative solutions that address the inspector's concerns while still meeting the functional requirements of the electrical system. Be prepared to discuss these options with the inspector and to make adjustments as needed. Fifthly, compliance plan. Prepare a detailed compliance plan that outlines the steps we'll take to ensure that the installation meets all applicable codes and regulations. This plan should include a timeline for completion and a list of responsible parties. Sixthly, communication. Maintain open and transparent communication with the inspector throughout the process. Keep them informed of progress and be responsive to their questions and concerns. Seventhly, flexibility. Be flexible and willing to make changes to the installation as needed to address the inspector's concerns. Demonstrate a willingness to work collaboratively to find solutions that meet everyone's needs. Eighthly, professionalism. Maintain a professional and respectful attitude throughout the process. Avoid confrontational or argumentative behavior, and focus on finding common ground and building a positive working relationship with the inspector. Ninthly, follow through. Once special permission is granted, be sure to follow through on all commitments and to complete the installation in accordance with the agreed upon plan. Tenthly, documentation. Document all changes and modifications to the installation and provide updated drawings and specifications to the inspector. By following these steps and demonstrating a commitment to safety and compliance, one can increase the chances of obtaining special permission with conditions from the electrical inspector. When considering the use of non-conductive housings for the termination boxes, it is crucial to select materials and designs that provide adequate protection against electrical shock, environmental factors, and physical damage. Firstly, material selection. Choose housing materials that are non-conductive, flame retardant, and resistant to environmental factors such as moisture, temperature, and corrosion. Common materials include polycarbonate, fiberglass, reinforced polyester, and PVC. Secondly, housing design. Design the housings to provide adequate physical protection to the termination boxes, preventing accidental contact with live electrical components and protecting them from damage from tools, equipment, or personnel. The housing should be sturdy and securely mounted to prevent them from being easily dislodged. Thirdly, ingress protection. Ensure that the housings provide adequate ingress protection against dust, water, and other contaminants. The housings should be rated to meet the appropriate IP, or ingress protection, rating for the environment in which they will be installed. Fourthly, ventilation. Provide adequate ventilation to prevent the termination boxes from overheating. The housing should not restrict airflow around the equipment, and ventilation openings may be necessary to dissipate heat. Fifthly, code compliance. Verify that the housings comply with all relevant electrical codes and regulations, including requirements for grounding, bonding, and overcurrent protection. Sixthly, labeling. Label the housings to indicate the presence of electrical equipment and to warn personnel to exercise caution. The label should be clear, legible, and durable. Seventhly, installation. Install the housings securely and in accordance with the manufacturer's instructions. Ensure that all fasteners and mounting hardware are properly tightened and that the housings are properly aligned. Eighthly, maintenance. Regularly inspect the housings for damage or deterioration and repair or replace them as needed. Keep the housings clean and free of obstructions. Ninthly, documentation. Document the installation of the housings in the electrical plans and provide updated drawings and specifications. Tenthly, grounding. Verify proper grounding of any metallic components within the non-conductive housing to maintain safety and code compliance. By carefully considering these factors and selecting appropriate non-conductive housings, one can effectively protect the termination boxes and prevent electrical shock hazards. When marking the working space as containing 24-volt low-voltage equipment, it is essential to use clear, visible, and durable signage that effectively communicates the presence of the equipment and any associated hazards. Firstly, sign placement. Place the signs in locations where they are easily visible to personnel entering or working in the area. Common locations include near entrances, on or near the equipment, and in areas where personnel are likely to be working. Secondly, sign size and visibility. Use signs that are of adequate size and visibility to be easily read from a distance. The lettering should be large enough to be legible, and the signs should be illuminated if necessary to ensure visibility in low light conditions. Thirdly, sign content. The sign should clearly indicate that the area contains 24-volt low-voltage equipment and should include any relevant warnings or precautions. For example, the signs could state caution 24-volt low-voltage equipment or warning electrical hazard. Fourthly, color coding. Use appropriate color coding to enhance the visibility and readability of the signs. Common color codes include yellow for caution and red for danger. Fifthly, durability. Use durable sign materials that are resistant to environmental factors such as moisture, temperature, and UV radiation. The sign should be able to withstand the conditions in the working environment without fading, cracking, or peeling. Sixthly, code compliance. Verify that the signs comply with all relevant electrical codes and regulations, including requirements for size, color, and content. Seventhly, language. Use appropriate language on the signs to ensure that they are easily understood by all personnel working in the area. Consider using multilingual signs if necessary. Eighthly, symbol usage. Use appropriate symbols on the signs to convey information quickly and effectively. Common symbols include the electrical hazard symbol and the exclamation point. Ninthly, maintenance. Regularly inspect the signs to ensure that they are in good condition and are still legible. Replace any damaged or missing signs promptly. Tenthly, training. Provide training to personnel working in the area on the meaning of the signs and the associated hazards. Ensure that they understand the precautions that should be taken when working near the equipment. By following these guidelines, one can effectively mark the working space as containing 24-volt low-voltage equipment and help to prevent accidents and injuries. When restricting access to the termination boxes to only qualified personnel, it is essential to implement a comprehensive access control system that effectively prevents unauthorized individuals from accessing the equipment and potentially exposing themselves to electrical hazards. Firstly, identification. Establish a system for identifying qualified personnel who are authorized to access the termination boxes. This could include issuing identification cards or badges that must be displayed at all times. Secondly, training. Provide comprehensive training to qualified personnel on the safe operation and maintenance of the termination boxes. This training should cover topics such as electrical safety, lockout tag-up procedures, and the proper use of personal protective equipment. Thirdly, access control. Implement physical access controls to prevent unauthorized individuals from accessing the termination boxes. This could include locking the enclosures containing the equipment, installing fences or barriers around the area, or using electronic access control systems. Fourthly, key control. If keys are used to access the termination boxes, implement a strict key control system to prevent unauthorized duplication or distribution of keys. Keep a record of all keys issued and require personnel to sign for them. Fifthly, visitor control. Establish procedures for controlling access by visitors or contractors who may need to access the area. All visitors should be escorted by qualified personnel and should be required to sign in and out. Sixthly, signage. Post clear and visible signage indicating that access to the termination boxes is restricted to qualified personnel only. The signs should be placed in locations where they are easily visible to anyone approaching the equipment. Seventhly, monitoring. Monitor the area around the termination boxes to detect any unauthorized access attempts. This could include using security cameras or motion detectors. Eighthly, enforcement. Enforce the access control system consistently and fairly. Take disciplinary action against any personnel who violate the system or attempt to gain unauthorized access to the equipment. Ninthly, auditing. Conduct regular audits of the access control system to ensure that it is functioning effectively and that all procedures are being followed. Tenthly, documentation. Maintain detailed records of all aspects of the access control system, including the identification of qualified personnel, training records, access control procedures, and any incidents of unauthorized access. By implementing a comprehensive access control system and enforcing it consistently, one can effectively restrict access to the termination boxes to only qualified personnel and help to prevent electrical accidents and injuries. When installing informational markings on the termination boxes, it is essential to provide clear, concise, and accurate information that effectively communicates the nature of the equipment and any associated hazards or special permissions. Firstly, content. The markings should include the following information. Firstly, the voltage of the equipment, in this case, 24 volts. Secondly, a statement that special permission has been granted for the installation, if applicable. And thirdly, any relevant warnings or precautions, such as caution low voltage equipment or authorized personnel only. Secondly, visibility. The markings should be placed in locations where they are easily visible to personnel who may come into contact with the equipment. Common locations include on the front of the enclosure, near the access point, or on a nearby wall. Thirdly, size and legibility. The markings should be of adequate size and legibility to be easily read from a distance. The lettering should be large enough to be legible, and the markings should be illuminated if necessary to ensure visibility in low light conditions. Fourthly, durability. The markings should be made of durable materials that are resistant to environmental factors such as moisture, temperature, and UV radiation. The markings should be able to withstand the conditions in the working environment without fading, cracking, or peeling. Fifthly, attachment. The markings should be securely attached to the equipment or enclosure to prevent them from being easily removed or damaged. Common attachment methods include adhesive backing, screws, or rivets. Sixthly, color coding. Use appropriate color coding to enhance the visibility and readability of the markings. Common color codes include yellow for caution and red for danger. Seventhly, code compliance. Verify that the markings comply with all relevant electrical codes and regulations, including requirements for size, color, and content. Eighthly, language. Use appropriate language on the markings to ensure that they are easily understood by all personnel working in the area. Consider using multilingual markings if necessary. Ninthly, standardization. Use standardized markings whenever possible to ensure consistency and clarity. This can help to reduce confusion and improve safety. Tenthly, maintenance. Regularly inspect the markings to ensure that they are in good condition and are still legible. Replace any damaged or missing markings promptly. By following these guidelines, one can effectively install informational markings on the termination boxes and help to prevent accidents and injuries. Discussing proposed solutions with the inspector prior to making any changes is a critical step in resolving code violation issues and ensuring that the final outcome meets all applicable requirements. Firstly, communication. Schedule a meeting or phone call with the inspector to discuss the proposed solutions. Be prepared to explain the rationale behind the solutions and to answer any questions they may have. Secondly, documentation. Provide the inspector with any relevant documentation such as drawings, specifications, or calculations to support the proposed solutions. This will help them to understand the technical details of the solutions and to assess their compliance with the code. Thirdly, flexibility. Be flexible and willing to modify the proposed solutions as needed to address the inspector's concerns. Demonstrate a willingness to work collaboratively to find solutions that meet everyone's needs. Fourthly, code compliance. Ensure that the proposed solutions comply with all applicable electrical codes and regulations. Be prepared to discuss the specific code sections that support the solutions and to provide evidence of compliance. Fifthly, safety. Emphasize the safety aspects of the proposed solutions. Explain how the solutions will improve safety and reduce the risk of electrical hazards. Sixthly, practicality. Consider the practicality of the proposed solutions. Ensure that they are feasible to implement and that they will not create any new problems or hazards. Seventhly, cost effectiveness. Evaluate the cost effectiveness of the proposed solutions. Choose solutions that provide the best value for the cost while still meeting all applicable requirements. Eighthly, timeline. Develop a realistic timeline for implementing the proposed solutions. Be sure to factor in any potential delays or challenges. Ninthly, approval. Obtain the inspector's approval of the proposed solutions before proceeding with any changes. This will help to ensure that the final outcome is acceptable and that the code violation issue is resolved. Tenthly, documentation. Document all discussions with the inspector and any agreements reached. This will provide a record of the process and can help to prevent misunderstandings in the future. By following these guidelines, one can effectively discuss proposed solutions with the inspector and increase the chances of resolving code violation issues in a timely and satisfactory manner. The NEC, or National Electrical Code, provides specific guidelines regarding working spaces around electrical equipment to ensure safety for personnel performing maintenance, inspection, or repairs. These requirements are outlined in Section 110.26, titled Spaces about Electrical Equipment. This section addresses several key aspects of working spaces, including depth, width, height, and access. The depth of the working space is determined by the voltage of the equipment and the condition of the surrounding environment. Condition 1 exists where there are exposed live parts on one side and no grounded parts or grounded parts suitably guarded or insulated on the other side of the working space. Condition 2 exists where exposed live parts are on one side and grounded parts are on the other side. Condition 3 exists where exposed live parts are on both sides of the working space. For example, for equipment operating at 151 to 600 volts, the minimum clear working space depth is 3 feet for condition 1, 3.5 feet for condition 2, and 4 feet for condition 3. The width of the working space must be at least 30 inches wide or the width of the equipment, whichever is greater. This ensures that personnel have adequate room to move around and perform their tasks safely. The height of the working space must be at least 6.5 feet or the height of the equipment, whichever is greater. This provides sufficient headroom for personnel to work comfortably and without obstruction. Access to the working space must be clear and unobstructed. There should be a clear path leading to the working space, and any doors or gates should be easily opened and closed. In addition to these general requirements, the NEC also includes specific provisions for working spaces around specific types of electrical equipment, such as switchboards, panel boards, and motor control centers. These provisions may include additional requirements for depth, width, height, and access, as well as requirements for illumination and ventilation. It is important to note that the NEC is a minimum standard, and local jurisdictions may have additional requirements that must be met. Therefore, it is always advisable to consult with the local electrical inspector or authority having jurisdiction before installing or modifying any electrical equipment. Failure to comply with the NEC requirements for working spaces can result in serious electrical hazards, including electric shock, arc flash, and equipment damage. Therefore, it is essential to ensure that all electrical equipment is installed and maintained in accordance with these requirements to protect the safety of personnel and property. The term foreign systems within the context of the National Electrical Code, or NEC, refers to systems that are not directly related to the electrical distribution system and may introduce hazards or interfere with the safe operation of electrical equipment. These systems can include, but are not limited to, piping, ductwork, and other non-electrical equipment that may be located within the working space around electrical equipment. The NEC generally prohibits foreign systems from being located within the working space around electrical equipment unless specific conditions are met. This is to prevent accidental contact with energized electrical components and to ensure that personnel have adequate room to work safely. The specific requirements for foreign systems are outlined in Section 110.26a of the NEC, which states that no foreign equipment shall be located in the dedicated equipment space. The dedicated equipment space is defined as the space above and below electrical equipment that is reserved for electrical equipment only. However, the NEC does allow for some exceptions to this rule. For example, foreign systems may be located in the dedicated equipment space if they are protected by a physical barrier or if they are essential for the operation of the electrical equipment. In addition, the NEC allows for foreign systems to be located above or below the dedicated equipment space if they are installed in accordance with specific requirements. For example, piping may be located above the dedicated equipment space if it is installed with adequate clearance and support. It is important to note that the NEC is a minimum standard, and local jurisdictions may have additional requirements that must be met. Therefore, it is always advisable to consult with the local electrical inspector or authority having jurisdiction before installing any foreign systems in the vicinity of electrical equipment. Failure to comply with the NEC requirements for foreign systems can result in serious electrical hazards, including electric shock, arc flash, and equipment damage. Therefore, It is essential to ensure that all foreign systems are installed and maintained in accordance with these requirements to protect the safety of personnel and property. The concept of special permission within the context of the National Electrical Code, or NEC, refers to a process by which an electrical inspector or authority having jurisdiction, or OJ, may grant permission to deviate from specific code requirements in certain situations. This permission is typically granted when strict adherence to the code would create an undue hardship or when the proposed installation provides an equivalent level of safety. The NEC allows for special permission in several different sections, including Section 90.4, which states that the authority having jurisdiction for enforcement of this code has the responsibility for making interpretations of the rules, for deciding upon the approval of equipment and materials, and for granting the special permission contemplated in a number of the rules. The process for obtaining special permission typically involves submitting a written request to the AHJ outlining the specific code requirement that is being deviated from and the reasons for the deviation. The request should also include detailed information about the proposed installation, including drawings, specifications, and calculations. The AHJ will then review the request and may request additional information or clarification. They may also conduct a site visit to inspect the proposed installation. If the AHJ is satisfied that the proposed installation provides an equivalent level of safety and that strict adherence to the code would create an undue hardship, they may grant special permission. The special permission may be subject to certain conditions such as the use of specific equipment or materials, or the implementation of additional safety measures. It is important to note that special permission is not a substitute for compliance with the NEC. It is only intended to be used in situations where strict adherence to the code is not practical or feasible. In addition, special permission is not transferable and only applies to the specific installation for which it was granted. Failure to comply with the conditions of the special permission or to obtain special permission when required can result in code violations, fines, and other penalties. Therefore, it is essential to consult with the AHJ before deviating from any code requirements and to obtain special permission when necessary.